Okay, radicals and geometry. So you have the square root of 81. Well, this is easy. This one's a quick one here. It's easy to simplify the square root of 81. That's rational, and it's not irrational because it equals 9. Okay, so you just put 9 as the answer. Now the square root of 17, since 17 is not a perfect square, the square root's going to be an irrational number, so you put IRR and the division sign. Okay, because see, if you square root 17 on a calculator, you don't want no part of that. Okay, and you can't go second PRB because it's irrational. It means it can't be written as a fraction. Okay, so you take 17 divided by 16. You'd start at 16, nothing going on there. 17 divided by 9, that's not divisible. It's not divisible by 4. It's divisible by 1, but what's the point? Because 17 divided by 1 is 17, so you just go ahead and circle the square at 17, okay? Alright, the square root of 108, okay? So 108 is not a perfect square, okay? So we put IRR with the division sign. Then we need to start dividing, so we divide 108 by 100. Nothing happening there. Then divide it by 81, still a decimal. You can't get a decimal. 64. 49's not working. Okay, 36 works. So we rewrite that into the square root of 36 times the square root of 3. The reason I do that, because the square root of 36 is 6. So you have coefficient 6 with a square root of 3. Okay. Alright, now the next part, now you get some more complicated radicals to simplify. So in this problem we have a square root, just one of them, but inside we have 3 factors, a 16 times an x third times a y to the 4th. So we want to split that. We're allowed in multiplication to split that square root up into 3 separate ones. So the square root of 16, the square root of x third, the square root of y to the 4th. So this one actually is this square root of 16 is not irrational, it's equal to 4, so we just flat out write equals 4. We don't do the dividing in the 2 square roots. Now when you get a perfect square like that, that 4 is going to be outside of our radical down here. Okay. No, there's not going to be a number inside. Okay, x third, there might be a variable inside, but there's not going to be a numerical coefficient inside. So x a third, you remember how to do this, you got 3 factors of x, and you want to break up the square root even further so that it covers 2 at a time. Now the point of that is x times x would be x second, but then the square root and the second power cancel out and I get a full factor of x. Now this does not cancel. We got this one full factor of x and then a square root of x. We're not going to put an exponent on this x because there's only one of them. So we have x outside and an x inside. Y to the 4th. So let's do that just like I did the x's. It's going to be a little bit different. So remember, 2 at a time. Okay. So y times y is y to the 2nd. So the square root and the 2nd cancel. Give me a full factor of y. Same thing here. Cancel. Give me a full factor of y. Now we don't have any y's remaining, so it's 2 full factors of y, so it'd be y to the 2nd. And if there's no square root involved, then that goes outside, just like the 4 did. So that's it, 4xy to the 2nd times the square root of x. Now simplify. Now you have 2 separate square roots. Well, what operation do we have? Okay. It's all multiplication. See, right there, multiplication. So that means there's 3 steps to simplify this. In step 1, we multiply the outside coefficients, while at the same time we multiply the square roots. Okay, so 3 times 2 is 6, and then the square root of 20 times the square root of 2 is the square root of 40. Okay. Now after that's been done, we need to simplify the new square root. So this 6 is going nowhere for now. We just drop that down, and then the square root of 40 we need to simplify. So 40 is not a perfect square, so it's irrational, and we know we need to put the division sign in and try to divide 40 by any of the perfect squares. So 40 divided by 36, that's not going to work. 25 is not going to work. 16 doesn't work. 9 doesn't work. But 4 sure works. Okay. So I write that into 2 square roots, and we put 4 first and 10 second. And of course, the reason we do that because the square root of 4 is 2. And now this 6 is here. Now the square root of 40 is now replaced with 2 square root 10. And the last thing we're going to do is, step 3, is simplify the outside. Okay? Because the outside coefficient is 6 times 2, which is 12, times the square root of 10. We can't multiply anymore because we have a coefficient and a square root. Here you had 2 coefficients that you're able to multiply. So if you see it's all multiplication with 2 separate square roots, I would think 1, 2, 3 would do well. Now this one's different. 3 times the square root of 2 plus 4 times the square root of 18. Now when we have addition, we need to get like terms. So we make a table, okay, because we don't have like terms. The 3 is multiplied by the square root of 2, and the 4 is multiplied by a different square root, which happens to be 18. So we're going to simplify these. 3 square root 2 times the square root of 2 on that side. 4 times the square root of 18 on that side. Okay, so 2 is 2 a perfect square. We'll drop this 3 down, okay. No, 2 is not a perfect square. So I put in the division sign. But the only thing 2 divides by is 1. Okay, so we don't want to just divide it by 1. If 1's the only thing we can divide by, we just keep it the same. So this one's going to stay the same. It's already simplified for us. Now 4 times the square root of 18, so I carry the 4. And 18 is not a perfect square, so we put the division sign. And I got a lot more options here, a lot more, but some more. 18 divisible by 16, it's not, but it's still divisible by 9. So then we drop that calculator, and then we rewrite that as the square root of 9 times the square root of 2, with the square root of 9 changing to 3. So it's 4, this 4, but the square root of 18 is now 3 times the square root of 2. Okay, now you need to simplify the outside. 4 times 3 is 12, and then square root of 2. Now you have like terms. Okay, we can now do the addition step because we have like terms. Both the 3 and the 12 are multiplied by the square root of the number 2. Okay, so we put the square root of the number 2, and then we add the outside coefficients. 3 plus 12 is 15. They are now like terms. They can now be added. Okay, now we're going to get into the 90-degree triangles. Okay, solve for x and y. So you have to find the value of x and the value of y. Well, this is a special triangle. We don't need to do the SOHCAHTOA. We do not need this if it's 45, 45, 90, or if it's 30, 60, 90. Those are special. Okay, so with special, we should write the degrees from lowest to highest. 45 degrees. Got 2 of them, and then 90 degrees. Now, the sides opposite these angles, that means straight across from them, always form ratios. Okay, so it's the same ratio every time. So across from the 45s, you got 1. Okay, just pick a 45, go across. Pick a 45, go across. So 1 and 1, and this across from your 90 degrees is the square root of 2. Now you're going to put those in parentheses. Okay, so across from 45, put 1. Go across from the other 45 and put 1, the same thing. And then across from your 90-degree angle, you put the square root of 2. Now we're ready to set up a proportion. Okay? You can't use Pythagorean theorem. You have to use proportions because you only know one of the sides. If there's 2 sides I don't know, okay, I need x and y, means I don't know 2 of them. I need to use proportions. Think in those terms. So x is the actual side length x is matched up with the ratio side length 1, And then down here, the actual side length y is matched up with the ratio side length 1. And then we pair both of those with the actual 15 with the ratio square root of 2. Okay? And then same thing here. This one's going to be kind of a tough one here, because you're going to take 1 times 15, and then you're going to divide that by the square root of 2. Well, 1 times 15 is easy. That's 15. Now remember what we said when we have a square root on the bottom, okay? And we're finding what x equals. I want to get rid of that. So what you do when the square root's on the bottom, you need to extend the division line and put square root of 2, square root of 2. So 15, because you can do that. If you have a ratio, it maintains its equivalence as long as you're multiplying by the same thing. So that's 15 square root of 2. You can't multiply those. But more importantly, on the bottom, the square root of 2 times the square root of 2 is 2 whole. Okay? Because if you remember, the square root of 2 times the square root of 2 is the square root of 4. Okay? But the square root of 4 is equal to the integer 2. So really, multiplying two identical square roots just gives me the value without the square root. Now you can divide, which is what you want to do. 15 divided by 2 is 7.5. Now you can put 7.5, you got to put the square root of 2 next to it. Or if it's a decimal, you can just leave it as a fraction, which would be 15 square root of 2 over 2. I'm fine with either form of that answer. Okay. Now, right here, you're going to take 1 times 15, because we're finding what y equals, divided by the square root of 2. Now we have the same thing. We can multiply on top. That's not the problem. The problem is the square root of 2. So we fix that problem by rationalizing the denominator. Okay. So 15 times square root of 2 is 15 square root of 2. The square root of 2 times the square root of 2 is 2. Okay? Because it's the square root of 4, but the square root of 4 equals 2. Okay, so again, 15 divided by 2 is 7.5 square root of 2, or if it's a decimal, you can just leave it as a fraction. Either way you're comfortable with, I'm good with. Okay. Alright, now this one's the same thing, it's just another special one. Different degrees means it'll be a different kind of ratio. Okay, 30, and these are your special right triangles, 30, 60, 90. Okay. So we go across the 30, and that's across from the 30 is always where 1 is at. Okay, so just put 1. Go across from the 60, and you know always across from the 60 will sit the ratio of the square root of 3. Then finally go across from your 90, and always there sits 2. Okay. Okay, so sorry I didn't put that down here. So square root of 3 and 2. And then of course across from your 30 is the 1. Same thing as last time. Put those in. Now you're solving for x here, you're solving for y here. Okay, so x is paired with 1. The actual is x, that's the actual side length, but 1's a ratio. Now for y, it's going to be y over 2. And then we need to team both these up where we know the actual along with the ratio. So it'd be 16 square root of 3. And the same thing here. Okay. We're going to get kind of the same messy thing that we did on the last problem. So we need to take 1 times 16. So 1 times 16, and then divide that product by the square root of 3. Okay. So 1 times 16 is 16. That's not the issue. The issue is 6. You can't divide these. Okay. So what we're going to need to do is, again, extend the line and get that square root out of the bottom. So you multiply by the square root of 3. Because we know that 16 times the square root of 3 is just 16 square root of 3. The square root of 3 times the square root of 3 is just 3. Yeah, it's the square root of 9, but the square root of 9 is 3 whole. Okay. So now you can divide those. 16 divided by 3. Okay. You can second PRB that. You can write 5 1/3 square root 3. Or you may just leave that as a fraction. because it didn't divide evenly. There's a fraction, a decimal, remainder. So however you want to do it, I'm fine with either form of that answer. Okay. Now in this one, we take 2 times 16. We're finding what y equals. Divided by the square root of 3. Okay, that's going to be 32 over the square root of 3. We have that same problem where we can't divide because we have a coefficient and a square root. So, an integer and a square root, however you want to call it, but you got to get that square root out of the bottom. So 32 times the square root of 3 is just 32 square root of 3. And the square root of 3 times the square root of 3 is just 3. Okay. Now you can divide now the 32 by the 3. I don't like that, so second PRB, 10 2/3. Now the square root of 3 is still there, or since it didn't divide evenly, you could just put 32 square root 3 over 3. Okay, either way is okay. Okay, now you're going to have to use some SOHCAHTOA. It flat out says that right here, sine, cosine, tangent. Sorry, the copy machine got cut off, at least on my copy. Identify the 3 trig ratios in the angle theta. You got to find sine, cosine, and tangent. Well, here's sine, cosine, and tangent right there. So we want to probably put those up, the SOHCAHTOA. So sine, cosine, tangent. And all we have to know is these ratios here. They're right here. So what's what? Well, we have to put the OAH labels on these. Okay. So across from the right angle is your H. And we know H is 34. Nice. Okay. Now to know the O and the A, you've got to write down where your reference is at. Okay. Now there's no other degrees. You never use the 90 for your reference. So you have to use that theta symbol. And that makes sense because the sine, cosine, tangent all have the theta after them. Okay. So theta is a reference. We just use the theta symbol. Theta. Okay, so I put up, there's my opposite, okay, and there's my adjacent. Okay, now we know sine is O over H, the cosine's A over H, and the tangent's the O over the A. So what do we know? Well, we seem to know that the O is 12 and the H is 34, so that's the end. We're done with the sine. I mean, you could reduce it by 2. You could divide them both by 2 to get 6/17, but, you know. Cosine's A over H. Now, we don't know the A, so leave that, then H is 34. Okay? Then O over A, 12, and then we don't have the A value, so we leave that empty. So I guess we have to find the A. Now, there's just one side we need to find, so don't use the proportions. Don't do that. Use the Pythagorean theorem. But don't write A squared plus B squared equals C squared. You want to go with A squared plus O squared equals H squared. Okay, makes more sense because A is what I don't know, so I leave that as the variable. O I know is 12. H is 34. So let's get rid of the second power, A to the second, 12 to the second. That's 12 times 12. That's 144. Then 34 to the second, 34 times 34. 1,156. Okay, now you use linear properties to solve. You're going to square root, but I don't want the decimal. I know you hate that, but... Okay, so I take 1156 minus 144. Okay, 1,012. Now, that sheet with the list of perfect square roots does not go to 1,012. If you want to know if it's irrational, you just square root it on the calculator. That looks irrational to me. So you best start dividing. Okay. Just start with the last one. 1,012 divided by 400. Nope. Oh, did that work? No, that's a decimal. 1,012 divided by 361. Nope. Divided by 324, nope. 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 Yeah, I hate this as much as you, but that's the way the math people want it. Okay. Nope. 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 Isn't this fun? Nope. 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 Okay, that worked. That's 4 and 253. So there's no decimal, so we would put 4 times 253. So the square root of 4 turns into 2. Okay, so your A is now 2 with the square root of 153. Okay, so 2 square root 153, and then down here 2 square root 153. And we're not dividing, so I don't really care if you put that square root on the bottom on those problems there. Okay, just leave it as a fraction. Okay, now find the 3 sides and 3 angle measurements of the triangle. First off, what we're going to do is get that 45 out of there. I don't like that there. Put 40. Because if it was 45, 90, that would be 45, and we wouldn't use the sine, cosine, tangent. We would use our 45, 45, 90 ratios with the 1, 1 square root of 2. So that's why I want it as 40 degrees, because the one on the test is not going to work out that way. So it's not a special, it's a random with the different degrees than the 30, 60, 90 or the 45, 45, 90, so those ratios will not work. Okay, so we got to find O, A, and H. Now first, let's label what's what. Okay, first, always good to have the SOHCAHTOA. If we have to use the O, A, and the H, we need to write the SOHCAHTOA, so we can always refer back to that. Some of you with poor memories, you know, back. So, what do we know? What do we don't about the sides? Well, that's the hypotenuse. We don't know that. Leave it empty. Now, for the O and the A, you always got to know where your reference is at. Now, we're not using the theta symbol because we actually have this degrees in here at 40. So use 40 degrees as your reference, not the theta symbol. Okay. O, and O is 17. So we have 17. Then the third side would automatically be the A, and we don't know that. So now we need 2 sides that we don't know. Okay, 2 sides, you need to go to proportions. Okay, but you need to put your reference angle in parentheses, and we'll be finding A here and H here. Now, of course, we know O, so we want to have O in each of the proportions. So proportion with A and O, we would use the tangent. So tan over 1. And that's O over A, with O being the 17, so get that out of there so we can find A by cross multiplying and dividing. So we find the product of 1 and 17, and then we divide that by tangent 40. So 1 times 17 is 17, divided by tan. I don't know why I'm writing that out when I can just use my calculator. Okay, so I come up with 20.26. Remember, there's no rule of what's supposed to be longer, O and A. H has to be the longest, we know that. So H and O, that would be the sine, okay? And then O over H. So, we don't know H, but we again replace that O with 17. Okay, so then I cross multiply and divide. 1 times 17 divided by the sine of 40. Okay. And we get 26.45. And there's your hypotenuse. Again, H is the king, and he's good. Angles are easy. That's a walk in the park. You know you got a 40-degree angle. You know the square is 90. Then we take 180, because all 3 of these have to add up to 180. Minus 90, minus 40. So that's 50 degrees. Okay. Okay, and then the last one, of course, is everybody's favorite problem, the area of the regular polygon. All sides are the same length. Well, we have a problem first. I didn't give you a side length. Let's pick an easy one. Again, without that information, you can't do it. So I'm going to go with 8 feet right there. Okay. Okay, the area of a regular polygon. That's S times SNA divided by 2. Or SAN divided by 2. I like SN better. Most mathematicians do it 1/2 times SAN. I like S times N times A divided by 2. Okay. Okay, so area equals, that's what we're finding. That's where I want the answer. And the area has to be labeled in square feet. Okay. Now the formula is right there. You just have to know how to carry it out. S is the side length, so it'd be 8 feet. Okay. N is a number of sides. Well, make sure you count the sides rather than just rely on me up there. 1, 2, 3, 4, 5, 6, 7. Yep, there's 7. So N is 7. Now A is that nasty apothem. So you make a point from there, perpendicular. That's a right angle. Now make the thing into a triangle. That does 2 things. We're able to find how long this is. What's half of 8? It's 4. 4 feet. Okay. We can also find this angle right there. Okay. By taking 360. Because on the very first problem I showed in this assignment, back when we did it, the assignment, I make no matter how many triangles I make, they all go in a circle. Okay. So 360 is the entire circle. Now you divide by how many central triangles, that would be how many of these things. Well, it's always divided by n because that's the number of sides, so it would be divided by 7. That's how many of those central triangles there would be, but I split the central triangles into just half. Okay? Again, don't draw this thing I'm about to draw. Okay? So you define the whole measurement of the whole thing, it'd be divided by 7 because there'd be 7 triangles like that. But then we're splitting those in half, which is dividing them by 2. Okay? So 360 divided by 7 divided by 2. Just put 25.71. Okay? That does happen, 25.71 degrees. Now take that triangle and just bring it down here. Okay? So, what do we know? Well, we know this is the apothem we're trying to find. You're always trying to find the apothem. Okay? When I know that, the side length of that, that's when I can put that right there. This is the apothem right there. You're always finding how long that is. You don't care about anything else but this. All the other crap's not important. I don't care how long this is. I don't care how many degrees that angle is right there. It's irrelevant. Okay? We're finding that. So you know you got 4 feet, not 8 feet. And you also know 25.71 is your reference point, your degrees. Okay. Now you need the HOA to do this. It's not a 30. You only know one side. You only know one side length, and it's not a 45, 45, 90 or a 30, 60, 90. So you got to do the OAH because you are going to need a proportion to solve it when there's only one side that you actually know. Okay. So here's H. That's not what I'm trying to find, but I label it just like I always do. Okay. And then your reference is the number of degrees, not the 90. It's got to be the 25.71 degrees. So you put that in a print. When you have that, you want to put that right there. And we need to go from there, and that's O. So we know O. What we really need to find is the A. So we're going with the A, and we're going to pair that with the O because we have the value for the O. Okay, so A and O. A and O is tangent. I've used tangent on every single one of these regular polygon area problems. That's always how it's going to be done. Okay, over 1. And remember, it's O over A, not A over O. Alright, so we know the O is 4. Once you get this down, don't mess around up there. Okay, so to find the A, we take 1 times 4 divided by tan 25.71. Okay, so 1 times 4 divided by tan 25.71. 8.31. Okay, that's your A. So go put that up there and you're good to go. That's how long that apothem side is, 8.31. Okay, so 8 times 7 times 8.31, click equals, and then divide that product by 2. Okay, that's going to be 232.68. Make sure you know where the decimal is at. Square feet. Okay, so yeah, the S, it starts off quick, but that apothem, yeah, find out how long it is from here to here. You make a right triangle, 4, half of that. You got to know how to find your degrees. Okay, divide by the number of sides, and then divide by 2. Okay, gives you right there. And you make that, and you always got to know you're looking for that. The nice thing about this is that's called the apothem. It's also going to be A, the adjacent side of the right triangle, with the reference 22.7 or 25.71. So that makes it nice, a little easy to remember that, gee, that's the apothem. It's also going to be the A that I'm trying to find. Okay.